Dear students, welcome to my classroom. Today we are going to start a new chapter. The chapter is mensuration. Students, in previous standards, you introduced with the surface areas and volumes of solid objects. And in this standard, we are going to learn few more things in continuation of that. So mainly in this class, we are going to deal with lateral surface area, total surface area, and volume of solids. Also, surface area of combination of solids, volume of combination of solids, and lateral surface area, total surface area, and volume of solids converted from one shape to another. So before going to start the problems in this chapter, let us recapitulate the formulae regarding to this chapter. So here we are looking at cuboid whose length is L, breadth is B, and height is H. Its lateral surface area is 2H into L plus B. Total surface area is 2 into LH plus BH plus LB. Also, volume is equal to L into B into H. I think all of you know how we deduce this formula in previous standard. And the second one is Q. Let L be the side of this cube. Then its lateral surface area is 4L square. Total surface area is 6L square. And volume is L cube. Okay. The next figure is cylinder. Let the height of the cylinder be H and the radius be R. Radius of the base be R. Then its lateral surface area is 2 into pi into R into H. That is 2 pi RH. And its total surface area is 2 pi RH in plus 2 pi R square. Okay. That is 2 pi R into H plus R. That means lateral surface area plus sum of the areas of base and top, which are in the shape of circle. And its volume is pi R square H. That is area of the base into height of the solid. Pi R square into H. Pi R square H. And this is a cone. Let the height of the cone be H and the radius of its base be R. Then its lateral surface area and L be the slant height. Then its lateral surface area or curved surface area is pi RL and total surface area is pi RL plus pi R square, that is curved surface area plus area of the base which is in the shape of circle, that is pi RL plus pi R square, and we can write as pi R into L plus R. And its volume is 1 by 3 pi R square H. And we know that here L square is equal to R square plus H square. And the next one is sphere. Let R be the radius of the sphere. Then its surface area is 4 pi R square. And its volume is 4 by 3 pi r cube. And the next one is hemisphere. Let the radius of the hemisphere be r. Then its lateral surface area, that is curved surface area, is 2 pi r square. And its total surface area is curved surface area plus area of the top, which is in the shape of circle. That is 2 pi r square plus pi r square, which is equal to 3 pi r square. And its volume is 2 by 3 pi r cube, which is half of the volume of sphere. Okay. So using these formulae, we are going to solve some problems in exercise 10.1. Okay. So let us start exercise 10.1. And the first problem in this exercise and in this chapter is a joker's cap is in the form of a right circular cone whose base radius is 7 centimeter and height is 24 centimeter. Find the area of the sheet required to make 10 such caps. Already we deal in previous class like these problems. So first here it is given that joker's cap is in the form of right circular cone whose base radius is 7 centimeters and height is 24 centimeters. So here the measurements of cap are given. Its base radius is 7 centimeter and 24 height is 24 centimeter, and the cap is in the shape of right circular cone. So now we have to find the area of the sheet required to make 10 such caps. So if we find the area of the sheet required to one cap, then we can easily find the sheet required to make such 10 caps, isn't it? So first we have to find the area of the sheet required to make one cap. And students, we know that the area of the sheet required to make one cap is equal to area of its lateral surface area. Because joker's cap do not have base. It is open and it is comfort to wear on head. So joker's cap is opened circular cone. So just we have to find the lateral surface area to make one cap. So here we have the circular cone, and here the radius of the base of cap is 7 centimeters and the height of the cap is 24 centimeter. Now we are going to find its lateral surface area, and we know that formula to find the lateral surface area is pi r L, but here the slant height L is not given. So first of all we have to find its slant height. So slant height of the cap is L is equal to under root r square plus h square, because here it is in the shape of right triangle, and in right triangle by Pythagoras theorem L square is equal to r square plus h square, where r is the base radius and h is height. So that L is equal to under root L r square plus h square. Now substitute the values of r and h in this formula. So r is 7 and h is 24, and this one is equal to 49 plus 576. So root 625, which is equal to 25. So the slant height of this cone is 25 centimeter. And now the lateral surface area of the cap is pi r L. That is lateral surface area of the cone is pi r L. And now substitute pi is equal to 22 by 7 and r is equal to 7 and L is equal to 25. So by cancelling 7 and multiplying 22 into 25, we get 550. So the lateral surface area of the cap is 550 centimeter square. That is, area of the sheet required for one cap is 550 centimeter square. So that the area of the sheet required for 10 caps is 550 into 10. That is 5500 centimeter square. So area of the sheet required to make 10 caps is 5500 centimeter square. Okay, students. And take the second one. A sports company was ordered to prepare 100 paper cylinders for packing shuttlecocks. The required dimensions of the cylinder are 35 centimeters length or height, and its radius is 7 centimeters. Find the required area of thick paper sheet needed to make 100 cylinders. Students, I think all of you know that the pack of shuttlecocks, it is in the shape of cylinder, and in this problem it is given that a company was ordered to prepare 100 paper cylinders for packing of shuttlecocks, and the dimensions of the cylinder are 35 centimeters in length and 7 centimeters in base radius. So now we have to find the required area of the paper sheet to make 100 cylinders. Okay. So here we have cylinder, and we have to make such cylinder, such 100 cylinders, and the radius of cylinder is 7 centimeters. The height of the cylinder is 35 centimeters. And what we have to find here, the cylinder should be packed. So that we have to find the area of lateral surface area and area of the top and area of the base. That is, we have to find its total surface area. Okay. So total surface area of cylinder is 2 pi r into h plus r. So now substitute the values of r and h in this formula. So 2 into pi is 22 by 7, and given r is equal to 7, h is equal to 35. And by cancelling 7, we remains with 2 into 22 into 35 plus 1, 42. And it is equal to 1848. So the total surface area of the cylinder is 1848 centimeters square. That is, area of thick paper sheet required for one cylinder is 1848 centimeters square. But we have to make 100 cylinders here. So now area of the paper sheet required for 100 cylinders is 100 into area of the paper sheet required for one cylinder. That is 100 into 1848, which is equal to 1,84,800. That is, the area of the paper sheet required to make 100 cylinders is 1,84,800 centimeter square. Okay. And now take the third one. Find the volume of right circular cone with radius 6 centimeters and height 7 centimeters. So students, here a right circular cone was given whose radius is 6 centimeters and height is 7 centimeters. Okay. Just we have to find the volume of this cone. And we know that the volume of the cone is 1 by 3 pi r square h. So just substitute the values of r and h in this formula. So 1 by 3 into 22 by 7 into r square is 6 into 7, 6, and h is 7. So by calculating this value carefully, we get 264. And what is it? 264 is it? The volume of the cone. Volume of the cone is 264 cubic centimeters. Okay. And the fourth one is the lateral surface area of a cylinder is equal to the curved surface area of cone. If their bases be the same, find the ratio of the height of the cylinder to the slant height of the cone. Okay, here it is given that lateral surface area of cylinder and curved surface area of a cone are equal. And also it is given that their bases are same. That is, the radius of the base is same. So we have to find the ratio of the height of the cylinder to the slant height of the cone. Okay, so here we have cylinder and a cone. So given that radii of cylinder and cone are equal, so let the radius of cylinder and radius of core be r, and let the height of the cylinder be h, and the slant height of the cone be L. Okay, so now it's given that lateral surface area of cylinder is equal to curved surface area of cone. And we know that lateral surface area of cylinder is 2 pi rh and curved surface area of cone is pi rl. So substitute these values in this equation. So 2 pi rh is equal to pi rl. And here we have to find the ratio of the height and slant height. That is h is to l. So from this we can write h by l is equal to pi r by 2 pi r. And by cancelling pi r in both numerator and denominator, we remains with h by l is equal to 1 by 2. So from this we can write h is to l is 1 is to 2. So the ratio of height of the cylinder to the slant height of the cone is 1 is to 2. Okay. So take the next one. A self-help group wants to manufacture Joker's caps of 3 centimeter radius and 4 centimeter height. If the available paper sheet is 1000 centimeter square, then how many caps can be manufactured from that paper sheet? So here the area of available paper is given, and also measurements of Joker caps that we are going to manufacturing are also given, that radius is 3 centimeter and height is 4 centimeter. And now we have to find that how many caps can be manufactured from given paper sheet, from the paper sheet available, which is whose area is 1000 centimeter square. Okay, so here the shape of Joker's cap is in the form of cone. Now it is given that the radius of the cap is 3 centimeter and the height of the cap is 4 centimeter. So first we have to find its curved surface area. Okay, so but the formula to find curved surface area is pi rl. So first we have to find the value of L, that is slant height. So the slant height of the cap is L is equal to under root r square plus h square. And now substitute the values of 3 and 4 in this one. So we get L is equal to 5. That is the slant height of the cap is 5 centimeter. And now lateral surface area of the cap is pi r L. That is 22 by 7 into 3 into 5. That is equal to 330 by 7. So the lateral surface area of the cap is 330 by 7 centimeter square. That is area of the sheet required to make one cap is 330 by 7 centimeter square. But the area of available sheet of paper is 1000 centimeters square. So now the number of caps that can be made from the given sheet, whose area is the 1000 centimeters square, is 1000 by 330 by 7. That is area of available paper by area of each cap. That is 1000 by 330 by 7. And from this we can write 1000 into 7 by 330, which is equal to 21.21. But the number of caps must be integer. So that is, it means that we can manufacture 21 caps from paper sheet available, and some sheet will be remain. This 0.21 remain, showing that some sheet will be remain after making 21 caps. So the number of caps that can be made from sheet of 1000 centimeters square is 21. Okay, because the number of caps must be integer. So take the next one. A cylinder and cone have bases of equal radii and are of equal heights. Show that their volumes are in the ratio of 3:1. Okay, students. In this problem, we have a cylinder and a cone, and it is given that bases are of equal radii and their heights also equal. And we have to prove that the ratio of their volumes is equal to 3:1. Okay, so here I have a cone and a cylinder, and it is given that the radii of the bases are equal, so that I am taking both the radius of cylinder and cone BR, and H be the height of the both cone and cylinder. Then the volume of the cylinder is pi r square h. Okay, volume of cylinder is pi r square h, as well as the volume of cone is 1 by 3 pi r square h. Now, the ratio of these volumes is equal to pi r square h is to 1 by 3 pi r square h. Now, by dividing by pi r square h, we get 1 is to 1 by 3. And by multiplying both the terms in this ratio by 3, we get 1 into 3 is to 1 by 3 into 3, and is equal to 3 is to 1. So the ratio of the volumes of cylinder and cone is 3:1. So we have to remember that the ratio of volumes of cylinder and cone having same radii and same height is 3:1. We must remember this result. Okay. Okay, students, that's all for today. And in next class, we shall solve remaining problems in this exercise, as well as we shall learn about the combination of solids. So until then, see you. Bye.